In this video, I'll be finding the average rate of change of a function on a specified interval. First, the formula for average rate. Equals f of b minus f of a all over b minus a. Alright, so for instance, let's say we're given the intervals 1, 5 and 4, 3.5. Oh yeah, just for a bit of a better understanding, the average rate formula simplified to look like y subscript 2 minus y subscript 1 all over x subscript 2 minus x subscript 1, which is also the slope formula, not to mention. All right, so back to our problem. I'm going to label each interval x with x1, y1, x2, and y2, and then just going to plug it in to the slope formula, which is the second one. And we have 3.5 minus 5 over 4 minus 1, which is equal to negative 1.5 over 3. And that is your average rate of change. All right, so for the next problem, we're given 2001, 243, and 2002 and 249. Then again, you're going to label your x1, y1, x2, y2, and then we're going to solve. So you're just going to plug it in and solve algebraically. Oh wait, there's actually more to this problem. Oop, excuse me. All right, so we also have 2001, 243, and 2004, 249. Then we'll label our x1, y1, and x2, y2. I mean, solving this problem is the same as, well, you follow the same procedure as solving for the first one. Oh my gosh, I'm getting my words mixed up. But it's just going to be two different average rate of change. All right, now I'll do 249 minus 243 all over 2002 minus 2001, which will give me 6 over 1, which is equal to 6. All right, and same for the next one, 249 minus 243 all over 2004 minus 2001 should equal to 6 over 3, which equals 2. And there you go. All right, so for this problem, we first want to start by plugging in our a and b. Actually, let me provide the formula once again. This time it will include f of b minus f of a all over b minus a. All right, so first, I'm going to start by plugging in our b, which is 5. So you have 5 squared equals 25. And then you plug in your 1, and you'll obviously just get 1. Now we plug it into our formula, and we have 25 minus 1 all over 5 minus 1. Oh yeah, I should have labeled my A and B just to make it easier for you to follow. All right, 5 minus 1 equal to 25 over 4. Oh wait, oop. Made a mistake. Sorry. 24 over 4, which equal to 6. And that is your answer. All right, next we have g of x equals x cubed on negative 4, 2. So same thing. You just plug in your a and b for x and then solve. So we have g of 2 equals 2 cubed, which equals 8. And then you have g of negative 4 equals negative 4 cubed, which equals negative 64. And then you just plug that in. Now you have 8 minus negative 64 all over 2 minus negative 4. And since we have two negatives next to each other, that means we will be adding. All right, and now you have 72 over 6, which equals 12. Our next problem, we have g of x equals 2x squared minus 9 on 4b. So first, I'm going to label my a and b really quick. And then we're going to start off by plugging in our 4. So then we have 2 times 4 squared minus 9. And then solving for 2 times 4 squared, you get 32 minus 9, which is then equal to 23. Now we'll be plugging in our b, so you have 2 times b squared minus 9, which would just be 2b squared minus 9. And then plugging in our function of b and minus function of a, which is 2b squared minus 9 minus 23 all over b minus 4. All right, and then when we combine negative 9 and negative 23, we get 2b squared minus 32 all over b minus 4. So 2b squared minus 32 can be broken down to 2 times b squared minus 16 all over b minus 4. And now we can factor out b squared minus 16 to get 2 times b plus 4 and b minus 4 all over b minus 4. And now you can cancel out the b minus 4s since we're multiplying and the numerator isn't being added or subtracted. And now you're left with 2b plus 8. Or it can be 2 times b plus 4, but whatever. For our next problem, we have k of x equals 4x minus 2 on 3, 3 plus h. So following the same steps, First, we're going to solve for our k of 3. So you have 4 times 3 minus 2, which equals 10, because you have 12 minus 2. And now we have to do k of 3 plus h, which equals 4 times 3 plus h minus 2. All right, and distributing the 4, you get 12 plus 4h minus 2. Combining like terms, we get 10 plus 4h. Now, we plug it in to our average rate of change formula. So you have 4 plus 10 minus 10 all over 3 plus h minus 3. And so now we can just simplify it. So get rid of the 10s, get rid of the 3. And we have 4h over h. Cancel out the h's, and you're left with 4.